Good morning, students. Welcome to chemistry class, chapter 3, Structure of Atom. In your previous class, you have learnt about Rutherford's alpha ray scattering experiment and how electrons and protons are arranged in an atom. Let's discuss the drawbacks of Rutherford atomic model. The atomic masses of different atoms could not be explained if only protons and electrons are present in them. Rutherford's atomic model could not explain the stability of the atom. He predicted that a kind of neutral particle must be present in the atom. He had not proved it experimentally. Discovery of neutrons by James Chadwick in 1932. Chadwick proved experimentally the presence of neutral particles and called them neutrons. His postulations were mass of a neutron is almost equal to that of proton. They are present in the nucleus of the atom along with the protons. In the Chadwick's experiment, alpha particles are projected towards beryllium target. The emitted particles are allowed to fall on paraffin wax, which in turn releases another type of particle, that is protons. From the energy calculations, Chadwick showed that the particles released from beryllium are uncharged and have the same mass as protons. He called them as neutrons. Rutherford's atomic model could not explain the stability of the atom. An electron revolving around the nucleus should continuously lose energy. As a result, it should be gradually pulled towards the nucleus and end up colliding with it. If this should happen, then the atom would collapse. So, this is the main drawback of Rutherford atomic model. A new theory was presented to explain this. In 1913, Niels Bohr presented a model of the atom, which is now called the Bohr model. The postulates of Bohr's atomic model are electrons revolve around the nucleus only in certain permissible circular orbits, otherwise called as shells. The first shell nearest to the nucleus is called K shell. The subsequent shells as we move away from the nucleus are L, M, N, O respectively. Electrons in each shell have been associated with definite amount of energy. Electrons in higher shell have more energy than those nearer to the nucleus. The energy of an electron remains constant so long as it revolves in its own shell, represent the energy levels. In Bohr's atomic model, the electrons revolves around the positively charged nucleus in certain shells, otherwise called as energy levels. Niels Bohr proposed that each shell or the energy level can accommodate a maximum of 2n square electrons, where n is the shell number. The first shell, K shell, where n is equal to 1, if you substitute n as 1 in 2n square, you get 2 into 1 square, that is equal to 2 into 1 equals to 2. So, the first shell, K shell, can accommodate maximum 2 electrons. Now, the second shell, L shell, where n is equal to 2. If you substitute 2 in the formula 2n square, you will get the answer 8. So, the second shell, L shell, can accommodate maximum of 8 electrons. Similarly, with the third shell, that is M shell, it can accommodate maximum of 18 electrons. The N shell, that is the fourth shell, it can accommodate maximum of 32 electrons. Now let's learn the electron distribution in neutral chlorine atom. The neutral chlorine atom has 17 electrons. According to Niels Bohr, out of 17 electrons, the K shell accommodates 2 electrons. The second shell, that is L shell, accommodates 8 electrons, and the remaining 7 electrons are accommodated in the third shell, that is M shell. So the electron distribution in chlorine atom will be as follows. 2 electrons in the first shell, that is K shell, 8 electrons in the second shell, L shell, the remaining 7 electrons in the third shell, that is M shell. So the 17 electrons get distributed in the 3 shells in this way. Let's see another example. Electron distribution in sulfur atom. Sulfur atom has 16 electrons. According to Niels Bohr, out of 16 electrons, the K shell accommodates 2 electrons, L shell accommodates 8 electrons, and the remaining 6 electrons are accommodated in the third shell, that is M shell. The model of the atom that emerged after Niels Bohr's proposal can be summed up as follows. Every matter is made up of atoms. An atom is no longer considered to be indivisible. In this class, you learnt about drawbacks of Rutherford atomic model, discovery of neutrons by James Chadwick, and Niels Bohr atomic model.